Now, the recovery in the computer system going to refer the restoring of the system into its normal operational state, because there is a possibility of many types of the error of the faults, due to which either the processes or the computer system is going to fail. And if it is failed, there must be certain method, there must be certain strategy, so that it can be restored for the effectiveness of the system. So you can say that the recovery is as simple as the restarting the failed computers or the processes, but it is a little bit complicated process, because we know that in a distributed system, many of the resources, either the memory or the files, are being allocated to the uh, executing processes. Um, for example, memory is allocated, and it may be possible that memory is allocated to a certain process, and that process might have logged that shared resources. Uh, and that resources may be the file or the memory itself. So if a resource has been allocated to a particular process, and if the process is going to fail, so it becomes very necessary to reclaim that allocated resources of the failed processes, so that it can be allocated to the other process. Now, if the failed process has already modified a database, then it is again an important aspect that all the modification which has been made in the database by a failed process is required to be undone. On the other hand, if the process has executed for few times, for some times before it is going to fail, it would be preferable to restart the process at the point, from the point of its failure, and resume its execution. By restarting at the point of the failure, the situation of having re-execute the process from the very beginning is to be avoided, because it may be very time consuming as well as the expensive too. Now, the distributor system used to provide the enhanced form of performance by concurrent execution of many processes, in which different processes are going to cooperate uh, while performing a particular task. And if one or more of the cooperating processes are going to fail, then the effect which is uh, due to the interaction of the failed processes on the other processes must be undone. Or the other way is to that every failed process would have to be restart from an appropriate state. Now, the second important facility which the distributed system used to provide is the increased availability. And this increased availability in the distributed system can be realized through the replication. And if a site is going to fail, then the copies of the data which are stored at that particular site will be going to miss the updates. So if it is so, it is going to the updates will becoming the it will become the inconsistent with the rest of the system, because when it will be operational during its failure period, it might have missed the updates, and so the system may be inconsistent while it is again become operational. So the recovery in such cases are going to involve the question that um, how not we are going to expose that particular system having the data inconsistencies, and bring back the failed site to up to date state, so that it will become consistent with the rest of the system. So we are in requirement of knowing that what are the causes, what are the types of the failure which can happen in a computer system, how a process can be recovered from failure, what will be the effect of the failing of the process on the other processes in the on concurrent system, and what will be the techniques by which it can be recovered. So we have certain basic concepts which are related to that, because we know that the system consists of a set of hardware as well as software, and the component, so it is made up of hardware and software component, and the system is designed to provide the specified services. Now, the failure of the system occurs when the system does not perform its services in a specified manner, whatever is being specified earlier. So, an erroneous state of the system is going to depict the state of the system, which could lead to the system failure by a sequence of valid state transition. And a fault is the physical condition which is different from what is the normal condition. Now, the causes of the fault includes it may be the design error, which is either the specification of the system or its implementation is concerned. Manufacturing problem, it may be damage due to the deterioration. It may be the external disturbances. It may be the environmental condition also, or it may be the electromagnetic interferences or the misuse of the system due to which the fault can occur. And as far as the error is concerned, an error is a part of the system state which differs from its intended value. So therefore, we can say that error in a system can lead towards the failure of the system. And just to recover from the system failure, we have to get rid of these errors in the system state. Therefore, we can say that the failure recovery is a process that involves the restoring of the system from the erroneous state to error-free state. This is the illustration which is going to manifest about the fault which can lead to the failure. And the fault can occur with the different kinds of activities. It may be because of the manufacturing problem. It may be the design error. It may be the external disturbances. It may be the fatigue or the deterioration of the system, which can cause an error. And with that point, due to that kind of error, the process or the system is going to fail. Now, there are different kinds of the failure which can occur in a distributed system, and we can classify the failures into 4 parts. The first one is process failure, in which the process is going to fail. Second one is the system failure, in which the system is going to fail. The third one is the secondary storage failure, in which we are not able to access the secondary memory, which is having different data which should be available to the rest of the users or the clients or the processes whenever it is required. And since it is a message passing system, everything is passing through the message. The communication is being done through the message passing. So it may be possible that the communication is going to fail. So we have 4 kinds of failure which can occur in the distributed system. So the first one in this classification of the failure is the process failure. In this, that either the computation of the results are going to become incorrect, or the process is going to cause the system to deviate from the specification, or the process fails to progress. Now, some of the examples of error which is being caused by the process to fail are the deadlocks, timeout, protection violation, wrong input which is provided by the user, consistency violation, etc. There are many things on which the error depends. Now, depending on the type of the error which is going to cause a process to fail, the failed process may be aborted or it can be restarted from the prior state, the state at which it has become fault. Now, if the failed process which is to be aborted or restarted from the prior state, where it can try to acquire the resources again. On the other hand, you can a wrong input in the very initial stage may require a process to be aborted. So it depends upon the condition. It depends upon the way by which the process is going to fail. The second classification is concerned with the system failure, because a system failure occurs when the processor fails to execute. It may be caused by the software error or it may be the hardware problem. If it is the hardware problem, the problem may be associated with either the CPU is going to fail, or the main memory is going to fail, or the power is going to fail, or the bus through which the data is being moving from one place to another is going to fail. So in case that in case of the system failure, the system is going to stop and it has to be restarted in a correct state. Now, as far as the correct state is concerned, it may be some predefined state, or it may be the prior state, which you can call it as a checkpoint of the system, which is being saved on a non-volatile memory or the storage. Now, if we assume that system behaves as fail stop processor, then this type of system have very simple failure mode operating characteristics. And the visible effect of the system failure are, it may be the system is going to stop the execution, and the internal state as well as the content of storage of that particular system are going to lost, meaning thereby the internal state as well as the content of storage which is going to be lost. Now, as far as the system failure is concerned, it is categorized into 4 kinds of failures. The first one is an amnesia failure. Second one is a partial amnesia failure. Third one is a pause failure. And fourth one is a halting failure. Now, let us discuss one by one. Amnesia failure occurs when a system is going to restart, or system restarts in a predefined state, and it does not depend upon the state of the system before it is going to fail. That is known as amnesia failure, in which the system is going to restart in a predefined state, and that predefined state is not dependent on the state of the system before it is going to fail. Now, the partial amnesia failure, it occurs when a system restarts in a state wherein a part of the state is the same as the state before the failure, and the rest of the state is predefined. And the predefined means it does not depend upon the state of the system before its failure. So this type of failure typically occurs, means a partial amnesia failure, it typically occurs in the file server, where the file server is going to crash and restarts, or when the system is going to be restarted from a checkpoint. The third one is pause failure. This pause failure occurs when the system restarts in the same state it was before the failure. And the halting failure occurs when system is going to crash and it is never start. It is not going to start ever. So these kinds of 4 failures comes under the category of the system failure. Then another category of failure which we have discussed earlier also, that is the secondary storage failure. And this failure is said to have occurred when the stored data on the storage device, the stored data may be the partial or the entire data cannot be accessed. Whatever data is stored, either partially or entirely, it is not able to be accessed. And this kind of failure is usually caused by, there are certain reasons, and the reasons may be either the parity error, it may be possible that head is going to be crashed, or the dust particle is going to be settled on the certain medium. So these are the certain reasons by which secondary storage failure can occur. Now in this failure, the contents are being corrupted and it is required to be reconstruct. The content which has been corrupted, it requires to be reconstructed from the active version with the help of log activity. Now we can avoid this secondary storage failure, and just to tolerate this secondary storage failure, the system can be configured with the mirror disk system. Now, what is the mirror disk system? The mirror disk system generally has 2 physically independent disks, which will be communicating with the memory and the CPU through the independent buses, as well as they have independent controllers also. And this is going to enable the stored data on each disk to be the mirror image of each other. And thus a system can tolerate this kind of failure by one of the disk subsystem, meaning thereby there are two disks which will be available. One and each of the disks are the mirror image, and both will be able to communicate with the separate buses as well as the controller. So if one disk is going to fail, other disk will have the information in the form of a data or the storage device, a storage unit, or the state of the process. The fourth kind of failure is the communication failure. It is also known as communication medium failure. And it occurs when a site is not able to communicate with the other operational sites which are available in the network. And the main cause of the communication medium failure is either by the failure of the switching nodes or the failure of the links of the communicating system. Now the failure of the switching node includes the system failure and the secondary storage failure. And the link failure includes the physical rupture of the communication channel or the noise in the communication channel. Now, as far as the communication medium failure is concerned, however, this communication medium failure also depends upon the topology and the connectivity which is being used for that particular system. It is not going to cause the total shutdown of the communication facilities. And the simple damage which a communication medium failure can be done in the form of a loss of the message, receipt of the message with the partial error, or the partition of the network. the partition of the network, when I say, then where subset of the sites may be unable to communicate with the sites of another subset, although the sites within the subsets can communicate with each other, but the different processes are not going to communicate. The sites are not going to communicate with the another subsets of this to the sites which belongs to another subset. So this is about the communication failure. So we have a strategy for doing the recovery from the failure, because failure recovery is a process that involves the restoring of the system from the erroneous state to the error-free state. And for doing that recovery process, we have two approaches. One is called forward error approach and forward error recovery approach, and another one is the backward error recovery approach, which is further divided into two strategies, that is operational based and the state based.
Company है.
So let us go and discuss about the what is forward recovery scheme and the what is backward error recovery scheme. In case of forward error recovery, if the nature of the error and the damages which is caused by the fault can be completely those errors in the process says state and enables the process to move forward, even though there are errors, there are faults, even though they enable the process to move forward. This technique is known as forward error recovery. And if it is not possible to foresee the nature of the fault and to remove all the errors in the process or the system state, then the system state can be restored to a previous error-free state of the process of the system. And this technique is known as backward error recovery scheme. Now, by seeing these two recovery scheme, the backward error recovery scheme is simpler in comparison to the forward recovery scheme, as it is since it is independent of the faults and the errors which are caused by the faults. And in backward error recovery scheme, we have a system which will be able to recover from the arbitrary fault by restoring to a previous state. But as far as the forward recovery scheme is concerned, it has low overhead because only those part of the state that is going to deviate from the intended value need to be corrected. However, this forward recovery scheme can be used only where the damages due to the faults can be correctly assessed. If it is not correctly assessed, then we cannot apply the forward recovery scheme. Now, as far as the forward recovery error recovery scheme is concerned, it continues from the erroneous state to make the selective corrections to the system state. It includes making safe the control environment which may be hazardous or the damaged because of the failure. And this scheme is also very specific to the system and depends on the accurate prediction, as I told earlier also. Because if we know that what kind of fault has occurred, what is the causes of the error, then only this scheme can be applied. As this scheme has less overhead, but it has certain disadvantages also, that to know the potential errors is a very tough job. It is having a very limited use and cannot be used for the general mechanism of recovery, error recovery. And it can be used by designing specifically for a particular system. Now, the backward recovery scheme is concerned. In backward error recovery, a process is going to be restored to a prior state in the hope that the prior state is free of errors. And the point in the execution of a process to which the process can later be restored, that point is known as a recovery point. And recovery point is said to be restored when the current state of the process is replaced by the state of the process at the recovery point. So whatever recovery is done at the process level is simply the subset of the actions which are necessary to recover the entire system. So in the system recovery, all the user processes that were active need to be restored to their respective recovery points, and the data which is already available in the secondary storage and which is modified by the process need to be restored to the proper state. We have certain advantages because of its simple to implement. It has the advantage that the erroneous state is going to be cleared, and it does not rely on finding the location and the cause of the fault. And it is used to recover from unanticipated fault during, including the design errors. But it has certain disadvantages also. We have certain problems with the backward recovery scheme. And the problem includes, the first problem is the performance penalty. The performance penalty, the overhead which is used to restore the process state to a prior state, it is going to be cost high. And second one is there is no guarantee that the fault will not occur again when the processing begins with the prior state. And the third one is that the some component of the system, it may be possible that it is not able to be recovered. So we have certain disadvantages also which are associated with the backward recovery scheme. And we have certain models which has been designed for the backward recovery scheme. And with that model, we have two way by which we can implement the backward error recovery, that is operational based, as well as told earlier, the operational based approach and the state based approach.